Hello everyone, I am Amaresh Sahoo, Vice President of Pricing and Data Analytics at Xometry. Today we're going to talk about building resilient AI pricing platforms and how we can make real-time decisioning at scale. As we know, the modern retail landscape has changed dramatically, and these days pricing decisions are becoming increasingly complex and time sensitive. And today we're going to talk about how we can build sophisticated AI powered that adjust price in real time basis based on market conditions, competitor data or competitor trends, and customer behavior patterns. These dynamic pricing platforms represent some of the more complex, challenging architecture or technology ecosystems today. So we'll briefly discuss that and cover some of the aspects around it. As we know, with pricing, the stakes are high. You can make a direct impact on revenue. The requirements are extremely complex, and we are dealing with massive data volumes from different data sources. We have to watch out the performance and the latency to maintain consistent performance. Reliability is another key factor here. You have to make sure the systems are reliable across geographies, and also we are maintaining the regulatory requirements to ensure that we are balancing the revenue impact, the complexity of the system, and with the reliability across geographies. So a little bit about the infrastructure architecture for low latency pricing, as the few aspects we'll cover here. One is the edge computing, which is essentially making sure you're distributing your computing resources across different regions, across pricing systems, so that you can reduce response time while maintaining consistency across different markets. You have to make sure when customers are on your side, you are not taking too long to show them pricing through instant quoting. You're making sure that you're pulling the information from different sources or systems in a way that is fast and also that is accurate. You need to have a container orchestration where we want to make sure there is automatic scaling based on the demand. And as the volume goes up, your system should scale seamlessly to provide the right information. As we talked about the complexity across dealing with different data systems, data consistency is another challenge. You need to have the real-time inventory or sourcing information. You need to have the competitor pricing data. You need to have customer behavior patterns. All those things end up getting together. So you have to make sure the data is consistent. And last but not the least, you have to think about network optimization. The content delivery networks that are optimized for API responses, dedicated network connections between data centers, and how we can have intelligent routing behind it to make sure we are minimizing the latency here. When we talk about the architecture, we need to discuss about data pipeline engineering, as we talked about the complexity of the data and accessing data or different types of data from diverse kind of systems. You need a constant stream processing where you're continuously ingesting and transforming the data across the systems. As I say, whether it's competitor data or inventory data or supplier data or customer behavior interactions, all these things needs to be processed in the right way. And you need to have real-time validation for that. So implementing real-time data quality checks. Of course, you cannot add more latency or processing delays. You need to be smart about how we detect anomaly, how we make sure that you're doing the real-time validation without compromising on the performance or the speed. Of course, you have to think about time-based features that can pull from historical data, and in a way that whatever net new or incremental data you're getting, you're basing your processing or calculation based on the incremental data in a way that you're not taking too long to process it. So key here is that you need to build the robust data pipelines that can handle this complexity while maintaining real-time performance. A lot of robustness in the technical architecture and operation processes go a long way here. The other thing we talk about is in pricing. That is as we think about pricing in today's world, most of it is AI driven pricing. So how do you make sure that you are deploying your machine learning models in a way that the models don't have latency issues, but at the same time you're providing the high accuracy across different type of market conditions or across all kind of the data aggregation or data processing we are doing. So you have to make sure you are allocating the memory correctly to all these models for a fast response time. How we can be strategic about where you can cache the prediction or where you have to make it real-time inferences for edge cases. So essentially, as you say, compartmentalizing the model in a way that some of the common scenarios you are caching the prediction, but for some of the edge cases you have the intelligence, or you can run the models to provide the right information. When you think about pricing, you have to continuously experiment. So how we have the right experimentation setup, whether it's A/B testing or multi-bandit or contextual bandits, how we can be smart about experimentation and how we can have the infrastructure to support the experimentation to provide the right customer outcome and financial outcome. And as we see most of the cases, these decisions on pricing they need to evolve over time. There will be cases where we may end up implementing something that doesn't work out as planned, so we need to have, or it leads to a system issue. In those cases, we have to have automated rollback triggers based on KPIs or some of the guardrails we have set up. So in a way, the systems we have or architecture needs to be robust enough to get the right data, process the data correctly, and support advanced models or machine learning models during the process. When you think about machine learning model management, we always have to think about how we can make them more effective and efficient. As we know, most of these models are combination of multiple models. There are models behind models. We have to continuously evaluate how efficiently we can combine predictions from these different models, how we can use them selectively depending on their strengths, how we control for the biases or any shortcomings of the model, to make sure that at an overall level we are providing the right information with right accuracy. Version control is key as we are evolving these models and continuously improving our predictions, improving the way we provide price information. We have to make sure we have version control so that you can roll back if needed, or you can refer back if you want to see how the new model is performing compared to the old model. Continuous performance monitoring is key as we evolve the models, as pricing has to be nimble and agile. We have to make sure you're continuously monitoring the performance in a holistic way, which when I say holistic way, you have to think about customer outcomes, financial outcomes. All those things need to be looked at together, and all those performance monitoring need to happen in real time, accounting for all the different data sources. Last but not the least here, as with these models, we need continuous training. So how we can make our infrastructure robust enough to ensure that the models are getting the right feedback and trained on a regular basis, so that we are making these predictions better and better over time. With these models and the complex data architecture, we have to keep in mind scalability and performance optimization. As we've discussed, with the demand volume, or as the volume of data grows, we need auto scaling so that we can capture the right input for the models. You have to balance the incoming volume and the computational need. Additionally, you have to make sure where in the databases you can optimize to make sure that we are able to manage heavy workloads, the complex queries or complex calls, we are able to drive them efficiently. So it goes along in terms of you not only just need the right and accurate predictions, you also have to make sure that we have the ability to scale and optimize the performance. The other areas will be caching and resource management. Again, multi-layered caching with aggressive caching can improve your response times, as we discussed a couple of slides ago, where what common scenarios we can cache so that you're not going through the rigorous prediction every time. So how do we make sure not just the prediction and also the input data is fresh, and how we can cache effectively to make sure that we are using the right combination of streamlining and also edge case optimization to drive the right performance. Some of the scaling patterns here will be nonlinear depending on product catalog size, market complexity, and algorithm sophistication. So we have to account for that as well. And additionally, as we say, the performance monitoring, traditional application performance monitoring tools may not capture the unique characteristics of ML-driven pricing systems. So we have to think about right customization that can track prediction latency, model performance, and business impact to provide better insights. Then we can talk about different reliability and fault tolerances. So there are different approaches here. The circuit breaker patterns, when external data become unavailable or internal services experience degraded performance, circuit breakers can prevent by isolating the problematic areas. We can think about graceful degradation as well. Strategies might involve serving cash prices using simplified pricing algorithms, or falling back to default pricing rules when we have issues with accessing the AI-powered pricing services. Similarly, data replication is key, because synchronous replication for critical data while using asynchronous replication for less time-sensitive information can balance performance and reliability requirements here. So data replication is key in case we have accessibility issues and we want to make sure we have a fallback fail-safe option here. As we talk about system architecture, disaster recovery and health monitoring are key. Again, we should have the ability to recover if there are issues in one geography or in one of the systems. So how we can consider both data restoration and model state reconstruction, as well as the time required to rebuild caches and restore full system performance. Comprehensive health checks. Health checks must go beyond simple connectivity tests. We have to make sure the pricing system is working as a whole. So comprehensive checks that not just look at the connectivity, but also verify model loading, prediction quality, and also provide real-time insight into the system health and system performance. I think that's the key here. So it has to be comprehensive. Additionally, because we're across geographies, across different systems, we have customer data that we need to use for pricing predictions. Security and compliance are key here. How we're ensuring data protection, how we are training the models on this distributed data, which essentially talks about federated learning, how we ensure regional compliance when you are across geographies, dealing with data for European customers, or dealing with data for North American or Asian customers. Depending on the region, we have compliance requirements. We have to make sure we are following the regulations. And with vast amount of data comes a lot of responsibility. How we are making sure we have the right access for the right people, and making sure that we are going with a role-based access that provides the right level of granularity for the right stakeholders. That goes a long way, and having the right authorization framework will also go a long way. With this, we talk a little bit about the operational excellence and monitoring. So again, for operational excellence, we need to have multidimensional monitoring, which needs to be comprehensive, whether it's technical metrics, model performance, or financial metrics. We need to monitor all of them. Incident responses, what are the automated mitigation strategies, what are the escalation procedures, what are the cross-functional response teams, how we do retro and post-incident analysis. All those things we need to account for. With that, we talked a bit about how the architecture or how we can build a AI pricing system. As we know, in the world of AI and pricing, things are continuously evolving. So there are future trends that we need to prepare for and we need to account for as things evolve. Edge AI capabilities, quantum computing, or real-time person are the ones where things are moving very fast. We have to make sure we're evolving our architecture and systems and to handle all those complexity that get introduced as we make progress in all those different aspects. So finally, building, as we talked about it, building a robust, resilient AI pricing platform is one of the most challenging engineering problems today. As we talked about its direct revenue impact, how decision is made by considering data from different systems, whether customer data or financial data or competitor data or market data. All those things lead to very nuanced decision making. That's where our systems, our architecture, they need to balance the competing demands for performance, reliability, scalability, and security while making sure we're adapting to the changing business requirements. As the retail landscape or marketplace landscape evolve, the AI pricing platforms will play a key role here, and they need to evolve to address some of the challenges we discussed during this presentation. Thank you so much. Appreciate your time, and it was a pleasure sharing some of the thoughts around this topic that I'm deeply passionate about. Thank you.